So yeah, good morning everyone, welcome. I hope you're all doing well. So today's session is part of the Making Net Zero Happen webinar series. And today's webinar will be focused on crematorium decarbonisation. So crematorium decarbonisation will become an increasingly more important for councils and local authorities to focus on to get to their net zero targets. This session is going to be exploring how the bereavement sector can start to transition to low carbon technologies and why this matters. So hopefully by the end of this webinar, you'll leave with a clearer picture on the options available and the different challenges that you'll need to consider. So I'm going to quickly start by introducing our speakers, if we can go to the next slide. So I'll let our speakers introduce themselves and give themselves a brief overview of their work. So Sam, if I can hand over to you.
Hi everyone, so my name's Samantha Smith. I'm the crematorium manager at Huntingdon Town Council. I've been working in bereavement services for well over 20 years now. I joined Huntingdon at the very start, so we're a new build crematorium. Thank you.
Hi, I'm Abigail Dombey. I'm energy engineer and director at Net Zero Associates. I project managed the High Crem project, which we'll go into in the presentation, but it was the world's first use of 100% hydrogen for crematoria decarbonisation.
Hi everybody, my name is John Mullins. I'm the estate decarbonisation lead for the Northwest Net Zero Hub, working with Abigail. We did a study over the last few months using Preston as a case study, and that's forming the basis of our input. And yeah, very pleased to be here.
Morning all. I am Manali Kulkarni, an Energy Projects Officer sitting within the Public Sector Decarbonisation team at the Greater Southeast Net Zero Hub. And the Southeast Hub has been working on putting together a crematoria decarbonisation toolkit. And over to you, Abigail.
Great, thanks everyone. Yeah, so I'm Abby. I'm one of the Net Zero Project Officers from the Northwest Hub, and I'm also a part of the Public Buildings team. And we've been basing on our analysis on the work that John and myself have been doing at Preston Crem. So as you can tell, today's speakers are covering a lot of ground, and throughout the session, they'll be sharing their different perspectives and expertise with you all. So thanks to all of them. Next slide, please. So before we have a look at the technical details, we're going to have a look at where today's webinar fits into the work that's been ongoing. So as you can tell, today's webinar is not a standalone event. So in the lead up to today's webinar, there's been work in the crematorium sector, and that includes the CDS Lancashire study, which took place in 2023, the Within High Crem project, which you're going to hear more about from Abigail today, the Preston Electrification study, which has been with myself and John, and then the Greater South East Hub Decarbonisation Toolkit that Manali's been working on. Again, after today's session, the Hub's content is going to be uploaded onto Net Zero Go. The Greater South East Toolkit is already there, and the Preston study will soon follow in the next coming weeks, and the recording of this webinar will also be uploaded onto there as well. Next slide, please. So yeah, I'm just going to quickly look over today's agenda. First, we're going to look as to why we should decarbonise, and we're going to go through things such as the climate science behind it and why the sector matters for local authority emissions. Then John and Abigail are going to walk us through the different technology options. And then after that, we're going to hear from Sam, Abigail onto the High Crem project. Then we'll have a look at the case study of the Huntingdon Crematorium, which will be covered by Sam. And this is a site that has already transitioned to electric crematories. And then we'll wrap it up with Manali. We'll host a 10 to 15 minute Q&A session. So if you have any questions throughout this webinar, please leave them in the chat and we'll try and cover them at the end. So next slide, please. And I'll hand over to John to look at why we should decarbonise.
Okay, well, I think we'll go through this fairly quickly because I think we can just next slide, please. We can. We're all here because we know we've got net zero emissions targeted by 2050. A lot of councils have got much earlier objectives put in. We've got numbers ranging from 2030, 2040. Next slide, please. The climate science is pretty clear. There's always a few dissenting voices, but the climate science is clear. We know we're breaking temperature records. That's become the new normal, and that's unsustainable. So wherever we are burning fossil fuels, we need to say, what's our long-term plan? So next slide, please.
All right.
In terms of Hi, Crem. I'm going to hand over to Abigail. We clearly have a challenge on gas emissions from crematoria.
Yes, so I'm based in the south and working closely with Adrian Worthing councils, and they found that their biggest single source of emissions was their crematorium, which has a colossal gas and a significant electricity consumption. So Worthing have done a huge amount of work installing a heat network across the town centre. So they're addressing their non-residential and residential properties, but they knew that they needed to address, or they need to address their crematorium to achieve their carbon neutral target, which is carbon neutral by 2030. You're on mute, John.
We knew that was going to happen. This slide came out of our Preston study. You know, the key driver on emissions from crematoria is the fuel use. The cadaver, the coffin, you can regard those as largely biogenic, renewable. The coffin, yes, there's resins, there's glues, but we can control that by putting in regulations or choosing what type of coffins we cremate. Outside scope, but just really for people's awareness, we've got things like the service, like the headstones we use. The headstone number there is, for example, shipping granite in from India. But the key driver is, what fuel do we use? Gas, electricity, that's the key driver, and that's what drives the choice over how do we decarbonize crematoria. Let's focus on the fuel that we use. Next slide. So technology options. Again, next slide, please. Essentially, we've got in terms of mainstream cremation, you've got gas, and we'll go into each of these in detail on the following slides. Gas, the current incumbent technology. Electric, although we say new, actually it's been around for a long time, but electric technology really moving into the mainstream. And then in the middle, we've got this hybrid where we've got cremators that can operate both on gas and electricity, potentially even fully one, fully the other. And what we'll do now is we'll just step through each of those technology options in turn. But I think there's a little bit around, well, if we go with electricity, what are the net zero advantages? Abigail?
So this is a very quick Energy 101. Apologies to those of us here who know this slide well, but basically the carbon intensity of gas has not changed and is not likely to change until there is a sizable proportion of biomethane in the grid, and even then it will only be diminishing a small amount. It's basically predicted to stay constant. Every kilowatt hour of John, can you put yourself on mute, please? Thank you. Every kilowatt hour of gas that you burn, you release 183 grams of CO2. For electricity, when I started in working in energy efficiency and decarbonisation, electricity was the bad big brother. It had a much higher carbon intensity than gas. That has decreased significantly, and it's now virtually, it's actually this slide slightly out because electricity already has a slightly lower carbon intensity than gas, and it is predicted. I've just seen this slide is from before the new government, before Labour moved into government. So there was a target to reach virtually net zero electricity by 2035. Now, under Ed Miliband, that target's actually been brought forward to have a clean power in the grid by 2030. So we are expecting to see virtually decarbonised electricity in the next 5 years. And it is decarbonising significantly every year as we install more and more wind farms and solar farms. So the short answer is gas does not decarbonise, whereas electricity, if you're switching over to electricity, that leads to a decarbonised power. John, back to you.
Thanks, Abigail. Look, gas, it's the current technology. Most of us on this call will be working with gas cremators. There's advantages. There's a high temperature flame. We've got airflow turbulence. And we've also got a reliable, predictable cycle time, 90 minutes on average, and that allows us to maintain scheduling. That's a really key point of the whole cremation process. Clearly, the issue is the CO2 emissions coming from that, and then we've got the legislation coming in, bringing in NOx controls, which will just require an abatement system. In terms of what do we need to consider, well, clearly there's this clash with net zero objectives. There's no costs associated with CO2 emissions, so up till now it hasn't been an issue. If we look at what the options would be if we were to carry on with the current technology, one is to say just carry on, but that's incompatible with local council national objectives. The one would be to say, can we go with biomethane? There's a number of challenges around all of this. One is very simple, that if the country's decarbonising, irrespective of what the cremator industry sector does, if everybody else decarbonises and comes off gas, who's left paying for the gas grid? Because nobody else is. So you're potentially facing really high standing charges over time if you want to stay on gas. So there's a challenge there. They are putting biomethane into the grid. There's an increasing, very large lobby group pushing biomethane. There's a number of challenges there, and we'll really come onto that when we talk through with hybrid cremators. But essentially, biomethane, when you burn the methane, you still emit CO2. Now, if you're taking it out of the grid, you burn it, you're then into offsets. And the question is, what's the long-term view of offsets? Are they going to be accepted? Are they not? We know Drax, for example, burning Canadian forests is increasingly coming under pressure with how the regulations are set up for sustainable combustion. So we'll touch back on biomethane in a minute. Okay, let's see. Hybrids. Hybrids, so this is the technology. The first units have started to be installed in this last year. We don't have performance data on hybrids. So a lot of our assumptions and analysis have been based on high-level estimates of how they perform. But essentially, they'll maintain your 90-minute cycle time. You can still use gas to warm up rapidly, and potentially they could be run as fully electric or fully gas. Potentially, we haven't got the data. Essentially, the hybrid cremator will have electric elements in it. You then have a gas boost, allowing you to add additional gas, especially when we're dealing with hard to cremate tumors, things like that. You can use a gas boost flame to try and accelerate the cremation, maintain process time. We don't know about the long-term maintenance. We've now got 2 dual technology systems in here, potentially, but that's an unknown at this stage. We will get performance results from hybrid cremators. Certainly the two companies using those are FT and Crematech. We'll get the results really sort of middle of next year, was when we'll get performance results. The challenge again with them is to say, well, okay, how much gas are we going to use? The gas use, if you're going to use gas boost to deal with a difficult cremation, that's under manual control. And one of the questions is, how heavy are we going to be on that gas button? Are we effectively dealing with a gas cremator with some electric elements that have incidental use? We don't know. The potential's there. The big problem again is we're sitting with the challenge of we won't hit net zero. We're still burning gas. So one of the options is, well, you could make it biomethane. The rules around biomethane mean that unless you tanker the biomethane in or you pipe it in directly from the source, your combustion will still need to be offset. So if you have a biomethane plant next to your crematorium and it's piped directly in from the source of a renewable source of biomethane, then you can say it's fully renewable. If you pay for guaranteed certificates of origin for gas that's gone into the grid, and then you're taking it out of the grid, then you can say your gas is from a sustainable source, but you're still emitting CO2 on combustion, and you will need to go to offsets. we're back to the question of what's the long-term viability of the offsets. The other challenge is cost. So when you're trying to go for guaranteed certificates of origin plus a carbon offset, you're more than doubling the cost of your gas. Gas is currently about, depending on your contract, say 6, 7, 8p a kilowatt. You will probably moving up to the 12 to 15 pence per kilowatt. Major impact on costs. And as soon as you move the gas costs up, electrification becomes even more attractive. So if we flick on now to the next slide, please. And this is what brings us to electric cremation options. I think the biggest thing that we've got to realize with electric cremators is that there is significantly less energy required than for gas. It's counterintuitive, but for an electric cremator, we only need, and we'll touch on this later, 10 to 20% of the energy that's used for gas. The big thing with a gas cremator is we're heating an airflow coming through the cremator, we're warming that up, and then we're pushing it back out. Yes, we'll have heat recovery, but essentially it's going out to atmosphere. So significantly less energy required. The carbon reduction, Abigail's already touched on the fact that the grid is decarbonizing. When we bring an electric cremator up to temperature, we then hold that temperature. So we get less cooling over the weekend. We maintain a higher temperature, and that means there's less thermal cycling of the refractories, which should give us improved maintenance costs. Again, the data is kind of limited, but the theory is that we should get lower maintenance costs. For our modeling purposes, we've always said maintenance costs stay the same until there's a really large body of evidence. Disadvantages with electrics. Look, you've got to have a DNO connection. There is a higher power demand, and the DNO connection, the cost of that will depend on where your cremator is relative to the grid. There's higher capital costs, so they are more expensive at the moment. I would believe as more manufacturers come into the market, we'll get increased competition. Maybe those prices will come down, but at the moment they are a higher capital cost. Operationally, they take a little bit longer than gas. So it's a longer cycle time, and it's a less predictable cycle time because you've got no control over the process. When the door opens and the coffin's inserted, close the door, it's then a very gentle cremation process, which is great in many circumstances, but also you've got no control. You can't accelerate it. There is a company, Adfield, who are coming to market. We'll get the first results from their electric cremator next year. They have an electric boost, which allows a superheated jet of air to be to replicate the gas boost. But again, performance data from that crematorium will be out in 26. The big thing then is the operating costs. Because you're using so much less energy, electricity is more expensive, but the net effect is lower electricity costs. And then because you've electrified, you can then start looking at adding PV to your site, battery storage, and essentially you're going down to lower costs. The odd thing with PV is, the sun shines during the day, we do our cremations during the day, we don't need the energy during the day. Essentially think of an electric cremator as being fueled with a renewable fuel. The coffin goes in, that raises the temperature of the cremator, and you don't need any fuel. There's zero energy input. You need the electricity overnight and on the weekends on a Sunday afternoon to keep the cremator hot so that it is ready for the Monday morning. That's when the power demand is.
I think that's not quite correct. As I'll come on later, we measured Lambeth's electrical demand, and the electrical use was pretty constant throughout the day and the night.
Okay, so we can discuss that. I think.
Yeah.
Next slide, please. Right, and we'll tick nicely onto you, Abigail, on high crem.
Yes, so thank you. So as I mentioned earlier, we carried out the world's first, we got funding from DESNZ, Department for Energy Security and Net Zero, to carry out the world's first 100% hydrogen cremations, because at the time we were convinced that this was the route to decarbonise crematoria. That's the angle that we came at. So we measured the gas and electrical demand of a natural gas cremation. We then carried out 53 hydrogen cremations, and we measured the hydrogen demand of those cremations. And then actually, well, first of all, when we did that, we found that hydrogen is technically feasible. You can carry out a hydrogen cremation. It works very much like natural gas. You can slot it in, apart from there's vast amounts of health and safety and health and safety issues that you need to be aware of, and because hydrogen is much more challenging to work with, as it has a much lower ignition, so it can ignite much more easily. And there's a lot of logistic challenges to working with hydrogen, because you bring it in at high pressure and you have to reduce the pressure. So we carried out 53 hydrogen cremations. We found that it is technically feasible, but then we did extensive work with Ricardo, looking at the economic and logistic challenges of working with hydrogen, and said that economically it would be much more challenging because it's vastly more expensive, and it has huge logistic implications. You'd have to have probably a trailer of hydrogen being delivered to site every day or every couple of days per cremator that you have. So it's, hugely challenging to work with. We found that there were some energy efficiencies that you would achieve with hydrogen, because it burnt more quickly, it got up to temperature more quickly. So it achieved about 5% energy efficiency, which was great, but it didn't offset the massive additional costs of working with hydrogen. We then actually went and measured the electrical demand at Lambeth Crematorium, who were very kind and allowed us to go in there and measure the electrical demand. And Lambeth is a fully electric cremator, much like Huntingdon. And we found that the electrical demand at Lambeth was about a 15th. It was a tiny fraction of the overall energy demand at Worthing. So, ironically, Lambeth electric cremator used less electricity than Worthing's natural gas cremator. So Worthing natural gas cremator used 2.4 megawatt hours of 2.4 nearly 2.4 gigawatt hours of gas a year and 225 megawatt hours of electricity. Lambeth just used 152 megawatt hours of electricity, so it's vastly smaller, much more efficient. Now, admittedly, Worthing's cremators were about 12 years old when we carried out the project, and Lambeth is much newer. So we also looked at the design conditions, and again we found that the electric cremators are still much more efficient. Ironically, the design conditions for the electric cremators were assumed higher electrical use than we measured, and we directly measured it and went back and checked it. But the modern natural gas cremators are slightly more efficient than Worthing's. However, still use vastly more energy than the electric cremators. Onto the next slide. Hopefully that's not confusing people too much. We've summarized it with a graph. So if all the crematoria in the country switched over to either natural gas or electric, we summarized how much energy they would require. So if they all switched to natural gas, they would use 329 gigawatt hours of natural gas a year and 25 gigawatt hours of electricity. That's for natural gas cremators. If they all switched to electric cremators, they would use 34 gigawatt hours of electricity a year as their entire fuel input. So you can see here very clearly the massive improvements in efficiency when you switch to electric cremators. Next slide, please. So as we mentioned earlier, CO2 emissions only meet net zero objectives in the electrified scenario. So If you switch over to hybrid, you will reduce emissions, but you won't ever meet net zero. If you switch to electric cremations, that's the only way that you can achieve net zero. And next slide, please. That's over to you, John. And
thanks, Abigail. So we've touched on hydrogen. So the study's been done. I think we can move on from hydrogen. There are another two technologies out there when you start looking around at, what's the landscape for low carbon cremation or equivalent. Resomation, which is effectively a technology to try and dissolve. There's no other word for it. Dissolve bodies. Again, it's an old, 30, 40-year-old technology from the States. There's a team up in Scotland trying to promote it. If you've got a tool and you're trying to sell it and there's a business, they'll be trying to promote it. I think we regard this as a niche product, even in the US, despite its history there. It's still very, very niche. On the electric side, there's microwave cremation, which is being mentioned as well. Again, looking at that, I think we'd say it's still at a very early technology level, and it's still got all the hallmarks of being a niche product at best. So from a local authority landscape, I think we can say those are not ones we need to worry too much about. Next slide, please. So, so what, electrification is the better option. Let's just go next slide. It's a blanket statement, but there's a caveat in there that the energy demand for an electric cremator is hugely dependent on how busy that cremator is. This is the curve where what we're looking at here is the number of cremations per day along the bottom axis, and then the energy demand going up the vertical axis. And that's quite a steep curve, especially as you get down to 1, 2, 3 cremations a day. It's very sensitive to that. And what we'll find is that local authority cremators tend to be operating at the sort of the middle left side of this chart, and the private sector cremators are operating around the middle right-hand side of the chart. Why? Because if you increase the utilization of your cremator, you get lower costs. Your fuel costs are lower, and therefore, from a private sector operator, that's where you want to be operating. So that brings out two challenges. One, the private sector certainly is going to be pushing unattended cremations, because that effectively, doing an unattended cremation allows people to play around with the flexibility of when does the cremation happen, but also it reduces costs. The problem with doing electric cremations, as we said earlier, it's not just the cycle time, moving from, say, an average of 90 minutes to 110 minutes, roughly. It's the unpredictability of that average, that the electric cremation can take longer. And that means if you're running a cremator at a higher utilization, so let's say we're doing 6, 7, 8, there's virtually no change in the fuel you need. But the problem is you've got less, it's much harder to schedule things in if you've got an unpredictable cremation time period. So what that means is that you wind up needing workforce flexibility, because you can't guarantee that, if we start a cremation at 4 o'clock, it will be finished by 6:30. That some flexibility comes in. The need for flexibility is less important on the left-hand side of this chart, because we're doing less a day, and in reality that the timings are less important. The advantages with an electric cremator is you can start immediately, you can come in, potentially have a couple of minutes ashing out, and then start straight away. Likewise, with the rules around not having an unattended cremator, say where there's a flame, you can at least have it attended up until the calcification process starts, and then just leave it overnight. So you can supervise the process until the flame dies down, and then again you've saved time with a sleeper cremation. Next slide, please. We've mentioned this earlier. This is the modeling that we've done. The sheer volume of gas required and the energy efficiency of an electric cremator means that we can effectively say that, you know, despite having significantly higher costs of electricity per kilowatt, the overall costs are lower. The hybrid number in there, that's an estimate. You know, although we can say it's 50% electricity, 50% gas, the trouble is you still have the standing charges. So the fixed portion of your cost goes up as soon as you pick a fuel, and then it's your kilowatts on top of that. The modeling we'd say would be that the electrified case is sufficiently cheap to pay back the increased capital cost of the electric cremator, you know, building modifications to put it in, alternative cremation costs during the install, and actually you come out functionally the same NPV cost as a gas cremator within a couple of percent. So, and given the fuel cost is so dependent on how busy your cremator is, that's where I think there'll be increasing focus on how do we manage the utilization of our cremators rather than leaving them at, you know, low levels of utilization. Let's move on. Next slide, please. If we think about the energy used at a crematorium site, it's not just inside the cremator. Quite often there's a gas boiler which is providing supplementary building heat. Now, when we say there's heat recovery from the cremator, quite often that's simply between the cremator and the abatement system, and effectively it's to reduce the temperatures going into the abatement system. With an electric cremator, there's significantly less heat loss, so there's less heat available for heat recovery. However, what we can do is be more efficient with how we go about doing heat recovery, and we can recover more of that heat. Then we can start saying, well, okay, is that insufficient to do full chapel and ancillary building heating? You may need to look at a supplementary air source heat pump. And that again pushes up your electricity demand a little bit, but it does mean you come completely off the gas. It means you can drop service charges, drop all the other costs associated with gas, and you're onto a single product, single technology. Again, that means that you're open to solar or other ways of generating power on site. Solar's known technology. You'll have a payback of 7 years, 6 years, something like that. And after that, effectively, your solar power is free. So it's another way of bringing those site costs down. If we step on to the next slide, please. Yeah. So transition factors, if we consider moving away from gas, you know, it's always a change management process, isn't it? You know, we know what we're used to, but if we're going to make the transition, there's a couple of things to consider. Yes, the fuel cost, which is a function of the unit price and the quantity. Our quantity goes right down, the unit price goes up, but net, you've got a reduction in energy costs. The cycle time, yes, the cycle time is longer with electrics. That has an impact on how you go about scheduling, but because you can start straight away in the morning, because you can leave, you know, a calcination overnight, there's no flame involved, but it does again save you sort of 20, 30, 40 minutes on a cremation with a little bit of workforce flexibility. Certainly on the middle of that chart that we showed, it shouldn't have too big an impact on how we go about running the cremation process. There's nil impact on the front end, on the chapel services and things like that. We may need some buffering capacity for those crematoria that haven't got it. You may want to look at some buffer capacity. So Preston, for example, have got refrigerated storage where they can hold over six coffins, and that decouples the chapel from the cremators and allows you to operate the cremators in a consistent way. Where you want attended and viewed cremations, so the family want to come in and actually see the coffin going into the cremator, then again, you're going to have to plan that a little more carefully because you can't guarantee a 90-minute cycle time beforehand. So you'll need larger buffers to ensure that that cremator is available for use. The maintenance, again, you know, the theory would be that the electric cremators are more thermally stable. There's less expansion and contraction on the refractories. In theory, that should lead to lower maintenance costs. You largely get what you pay for. And and what you expect. And I think the more knowledge we develop about our cremators, the more we can hold the maintenance teams to account and actually expect good service in terms of call-out times, responsiveness, and preventative and predictive maintenance. There's a few queries around the thermal stability of the abatement systems, but again, it's very early days at this stage. So I think at this stage we're holding, certainly in the modelling we did for Preston, we held our maintenance costs level. I think that's fairly conservative. We should be seeing a reduction. Capital cost, as said, electric cremators are more expensive. There's two designs, one where they will build them in situ, depends on which manufacturer you go for, and that therefore has less capital cost on modifying the building. Others, they're made off site and they're brought in on a truck and craned into position, and that might mean capital cost of doing some building modifications, taking a wall out or something like that. Likewise, what are you going to do while your cremators are being replaced? Are you doing alternative off-site cremations while running the chapel? Are you shutting down? Are you going to consider a portable cremator on site? All of those costs need to be factored in, along with project management costs, contingency costs. In our study for Preston, I think we'd say that electrics still come out similar to the status quo. So with that as a summary, I think let's just move on to what does it mean in practice. And probably the star of the show is Samantha here, who runs Huntingdon's crematorium, purpose-built electric facility, but she's got lots of experience running gas crematorium as well. So over to you, Sam.
Thank you, John. So my experiences in 2013, Huntingdon Town Council faced a critical challenge. Our burial space was running out, so this wasn't just a logical issue, it was a question of how we could continue to serve our community. At that time, the town clerk made a bold decision to push forward with a crematorium as well. So two suppliers came and tendered. One of them was the ATI gas cremators and the other was DFW. Obviously, DFW supply electric as well as gas. They invited councillors to their headquarters to look at their machines, and councillors all decided this was the way forward to use electric. If I can have the next, thank you. So our project includes the crematorium, a cemetery, memorial garden, wake building, 2 greenhouses and a large depot and compound. Everything was planned to create a respectful, sustainable environment. To give you an idea of the scale, the cremators alone cost £1.2 million. Our annual electricity bill is about £100,000 a year, and the cremators alone use approximately 70% of our overall energy use. One of the most innovative features is our heat recovery system. Excess heat from the cremators doesn't go to waste. It's used to heat our crematorium and the greenhouses. These greenhouses grow plants and shrubs that are used throughout the town, in cemeteries and on the actual crematorium site itself. So the energy we recover directly benefits the community. When there is little demand from the heat recovery, we also have 2 air source heat pumps that step in to heat the facility. Could I have the next slide, please? This slide shows how our electric cremators performed over the past year. So this was April 24 to March 25. The chart shows the average energy consumption per hour for each cremator, calculated by dividing total monthly consumption by the number of hours in that month. So for example, in April, the total installation, including cremators and the abatement, used 7,579 kilowatts. April has 30 days, so that's 720 hours. Divide 7,579 by 720 and you get 10.53 kilowatt per hour for a cremation for cremator 1. What's interesting on this graph is the variation between the 2 cremators. So cremator 1 stayed fairly consistent, averaging around 10 to 12 kilowatts for most months. Cremator 2 had more fluctuations, peaking at 16.61 in October and dropping to 5.90 in March. These differences reflect operational factors such as service volumes, maintenance schedules and seasonal demand. For example, in October, cremator 2 coincided with a breakdown as well as servicing, which meant that the cremator had to be cooled twice, I think, that month, and then obviously reheated to the operational temperatures. Even with the variations, remember that 70% of our total energy use comes from the cremators. That's why our heat recovery system is so important. It turns the energy into resource for heating greenhouses and supporting our planting programme across the town. Monitoring the data helps us optimise performance, reduce costs and improve sustainability year on year. Next slide, please. This slide shows the total energy usage for both cremators together with other usage on site, which would include, we have a wake building, we've got electric charging points throughout the car park. So in total, it equates to 267,000 per year. Estimated emissions of this is 47 tonnes per year. Gas is considerably higher at 150 tonnes. Using electric cremators, we've avoided 102 tonnes per year. So it's a huge step forward for sustainability in bereavement services. By using cremators and sourcing renewable energy, we've dramatically reduced our carbon footprint while maintaining service quality. Next slide. So this was just to show you an overview of the actual maintenance we have on the cremators. Our maintenance cost is probably the same as gas. We're looking at £60,000 a year. The most expensive component in the machine is the particulate filters, which need replacing every 18,000 cremations. So from our figures, our numbers per year, we're looking to change them every 3 to 4 years, and we've got 2 cremators. That's a picture of actually our cremators. So the servicing schedule, we have 2 main service types. We've got an interim service, which only involves 1 day. There's no cooling required. And they do lubrication, check switches, motors and drive belts. And then we have our annual servicing, which takes 2 days and requires a cool down. So they do an overall service, they calibrate the oxygen analyzers and the compressors as well with that. A comparison between gas cremators and electric, I think it's generally lower maintenance complexity than as opposed to gas cremators. Servicing is cleaner and safer compared to gas. There's no burners or gas valves to maintain, fewer moving parts and less stress on the brickwork. With gas cremators, you tend to have 3, 6 and 12 monthly interval servicings, so ours are a lot less. So overall, it means electric cremators are safer, cheaper in the long run, more convenient, and most importantly, better for our planet. Thank you very much.
Thank you all to the speakers for their presentations. Just to reiterate before we move on to the Q&A session, since this webinar is being recorded today, it will be made available online after the event in case you'd like to rewatch it or any of your colleagues haven't been able to join us today. The slides will also be shared separately. So moving on to the first question that we have, it's about if there are any alternatives to cremation and if there's any evidence around relative impact of burial and other options. Since cremation is a relatively modern approach, are there any reasons as to why it would be needed or wanted?
Can I jump in here and answer this one?
Yes, please.
I think cremation is not a modern approach. I think it's been going on for thousands of years across the world. Burial is the lower carbon option, but we do not have enough physical space to carry out burials unless we decide to do what happens in some Catholic countries where you build concrete tower blocks and you put coffins in little portholes in the concrete tower block where they will never decompose. So culturally, one thing that we've not mentioned actually, culturally, around 80% of us in the UK choose to be cremated. Personally, I think it's actually, maybe this is me as an engineer, but I think it's easier to change the technology, and we know that there is a an alternative to a gas cremator that will deliver decarbonisation. I think it's easier to change the technology than to change the cultural mindset across the country. So yeah, I think we know that the route to decarbonise cremation. So for me, that's the sensible approach.
Yeah, I fully concur, Abigail. In the Preston case, we're doing 1,300 cremations a year, burials 250. So I think that probably addresses that. Let's change the technology rather than societal change. That's too big a question, and outside the scope of certainly of this webinar. Manali, back to you.
Thanks, John and Abigail. The second question is that it was mentioned that electric cremators run all the time and cremate more gently with a cycle that runs longer. Is there an issue around capacity? There's a couple of questions more, which I can just read out. What are the relative costs of either building fully electric at the outset or converting from gas to electric? Also, what would the payback period be for retrofit?
Can I answer the question about the length of time for cremation for electric?
Yes, please.
So with our electric cremators, we are carrying out a cremation between 1 hour 20 to 1 hour 40. The most longest one we've done took 3 hours, and that was because the body was just wrapped in a shroud on a bodyboard, so there was hardly any fuel. The coffin acts as the fuel for the cremation.
And just to add there, we spoke to Lambeth before they switched over. So Lambeth was the first crematorium to switch from natural gas to electric. Huntington and Thirsk had built fully electric cremators, but they were new crematoria. Before they switched over, they were concerned about the electric cremators being longer. That's something that that is a real concern in the bereavement industry. That's one thing that you speak to people about, that they're very concerned about. And the manager there discussed with staff the possibility of them working overtime to cover extended shifts as a result of the cremations taking longer. And then the staff were all incredibly disappointed because on average the cremations didn't take any longer at all.
And then I think, Manali, your other question, there were lots of questions in there. I think the other question was then what's the capital cost of changing over? You know, it very much depends on which manufacturer you're going for. There's quite a range of prices out there, and it will also depend on the unique situation of your crematorium. One of the big cost elements we've seen is the D&O connection cost. You know, I think we had the Huntington quote there that was 1.2 million for 2 cremators as a new build. That's perfectly reasonable. We've got costs anywhere from 700,000, 800,000, 900,000 per cremator if they're coming in. But then the D&O connection cost, certainly in the Preston case, was 750,000. So it's a really material one, and that's because it's kilometers away from the nearest substation. But even then, when you took an NPV view over 20 years, it paid off. You've got to be clear about what are the components of that cost, and as I said earlier, it's breaking out. It's not just the cost of the cremator; it's what's the cost of installing it, building modifications, alternative provisions, things like that.
Thank you. And I think the last question in there was also what would the payback period be for a retrofit?
That'll depend. I mean, these are 20-year assets. In terms of financing it, depends on how it's financed and what rate you're going to finance it at. The case study we looked at was over a 20-year period. It would pay back over 20 years. What the key then is, when you do your next replacement, you don't have a D&O connection cost. You're already set up, and we've excluded the benefits of potentially extended solar and things like that. So case dependent. It's not a case that you can put it in and you get payback in 5 years. No, this is a strategic change aiming to be nil overall cost while making a technology change. But depending on your situation, if you're a high volume cremator going electric with solar, you know, when we were speaking to Memoria, they're looking at one of their sites potentially going to zero need for imported power, because they will do it all off solar, and they are high volume. So it's very case specific.
Thank you. And over to the next question. Can you reiterate why the length of cremation will differ more with electric, and also confirm that energy usage is around 152 gigawatt annually?
If you want me to pick that up, the why does the time vary? Really, it's because you can maintain the 90-minute cycle time in a gas cremator, because the operators can observe the cremation process and then say, right, you know, this cremation is taking slightly longer, either due to body size or the presence of tumors, and they can then effectively press the gas button. Samantha, by all means, jump in with your experience. I haven't operated a cremator, but you know, you can effectively press the go faster button, use more fuel, and accelerate the cremation process, and you can maintain that 90-minute cycle time, which is a huge benefit to scheduling and planning. In an electric cremator, there's no turbulence, there's no additional energy being put in. You have a hot box, and the coffin gets inserted, the door gets closed. It's a very gentle cremation process, which is ideal in the case of, you know, certainly cremating infants and things like that, because you're guaranteed ash recovery. But likewise, there's no go faster button. You know, these take days to warm up. So if you press the more electricity button, you're not going to see any change. So the cremation process therefore takes as long as the process will take, and you don't know if there are significant tumors present until you see that the process is taking longer. However, we are talking averages, and I think, as Abigail's study showed, you know, at the end of the day, most of this is about potential rather than actual.
Yeah,
so it potentially can take longer, but on average, you can work to 110 minutes and it nets out. Abigail?
And just to follow up about the question about the energy usage, I did a lot of work with DFW Europe, and spoke to them in March, and they said that at the time they had carried out over 82,000 electric cremations in 35 cremators. Now, I'm sure that number will have significantly increased since March, but at the time, out of 82,000 cremations, they found that the average load that was achieved was less than 15 kilowatts. And so an average load that will work out as 131 megawatt hours per year. So less than 152 gigawatt hours. So, yeah.
And let's just put that in perspective. 15 kilowatts, a 3-pin domestic plug gives you 3 kilowatts. You know, that's the scale. We're not talking, you know, we need power, and the reason why there's a DNO cost is because you need power to bring the cremator up to temperature. You saw in Samantha's chart that big spike in October because they had 2 shutdowns and warm-ups. So power is required to warm up, and you want to warm up as quickly as possible. It still takes a couple of days. But once you're at temperature, you have an insulated box. It's at temperature, 12, 15 kilowatts, whatever the figure is. You know, it's a few 3-pin plugs that are plugged in effectively just to keep it at temperature. Samantha, any comments from you on the?
No, what you said is correct. I think for our biggest fear was obviously the time it was going to take cremating. We had the luxury that we've got 2 cremators, so we're still not at full capacity. We run both cremators because from experience with DFW, they said that's the best thing to do. So for us, we just charge the coffin in and leave it, because like John said, there's no gas burners or anything like that you can turn on. So for us, we're very lucky, but obviously you would have to look at your overall site as to how many cremations and things you have per year. So we're just lucky because we had 2 installed for future.
Thank you. Just conscious of time, we probably might take on one last question. We'll see how it goes. There's been a number of
questions about DNO and the connections, which we could, well, there's questions about heat networks as well, which I can answer very quickly, which is I don't at the moment know of any crematoria that connected up to heat networks, primarily because crematoria tend to be in the countryside or on the outskirts of towns and cities and not right in the heart where it would make a geographical sense to work with a heat network. So Worthing has a great heat network, which is brilliant, but Worthing Crematorium is 15 miles away in the middle of the South Downs.
Yeah, we also get anecdotal comments that, you know, heat networks are new to the UK in many areas, and their comments about, well, where are you getting your heat from? And there's a perception that, you know, getting the heat network from the crematorium is in some way a negative. So at the moment, I think I'd agree with Abigail there. We're not aware of any crematorium feeding into heat networks. The other thing is, if you're planning on feeding into a heat network with a gas cremator, you've then got to say, what happens when we come off gas? What happens then? And actually, is it viable? You know, even with Samantha's purpose-built Huntingdon crematorium, there are a couple of air source heat pumps to supply supplementary heat, rather than being a large base load that you can supply the local community with low-cost heat. So it's a nice idea when you go through the practicalities and the costs of laying insulated pipes through a half a mile trench. It falls over.
Thank you. And just moving on to one last question, probably before we conclude the session, is the chart on slide 21, if I just bring that up, on running an electric cremator. Is this chart for 24 hours a day for 7 days a week in order to maintain efficiency?
Yeah,
that is there no shutdown of the process each week?
There's no shutdown of the process. You warm up. You know, I think in Samantha's case, you know, ideally you'd warm up. You've got an annual shutdown for cold maintenance, but once you warmed up, you stay at temperature. But
the cremations don't need to be carried out. In the UK, cremations tend not to be carried out 24 hours a day. Yeah. So whilst the cremator is switched on and is warm, it's not carrying out cremations 24 hours a day.
You're not doing cremations. You're running cremations Monday to Friday as normal. Again, speaking to Memoria, they might have a weekend team that comes in to clear backlog on a Saturday, but that's because they run really high utilization. But you'd maintain temperature through the weekend, so you still start on Monday. There'll be a slight temperature drop, but it's really not much. You'll again do electric boost or you'll feed in power just to maintain that temperature. What you don't want to do is go cold, because then you're into a couple of days to warm back up again.
So even with our servicing, our cremator will cool down to 200 degrees, and then obviously we heat it back up to operational temperature. But when we opened, both machines took approximately 3 days to reach temperature, and then they reach a standby temperature, which is around about 650 degrees. And then obviously we preheat it to get it to the operational temperature on a Monday morning. So it will probably start Sunday evening, and then by Monday morning, 8 o'clock, it's at temperature to charge the first coffin.
And your operating temperature, Samantha, is what, 750?
750, yeah.
Yep.
Thank you. Just conscious of the time, apologies we haven't made through all the questions today, but we've noted those questions down, and we'll probably find a way to answer those. The slides and the recording of the event will be shared on our social media pages. And if you do have any questions, please do feel free to get in touch with your regional net zero hubs. And I would like to thank you all for joining this session. In case there are any closing remarks.
If people have questions specific for the webinar, can they address them to you, Manali, and then we can respond to them within between ourselves and then get back to people?
I think we'll post Q&As on the Net Zero website. Brilliant. So people can go back and refer to them. Okay, thank you.
Thank you all for joining.